In this video we're going to be looking at trigonometry, this time with a focus on finding missing angles. Just to recap, when I start with any trigonometry problem it's important that I label the sides correctly. The hypotenuse is always located opposite the right angle. So in both of these triangles the hypotenuse is in exactly the same place opposite the right angle. In the triangle on the left the angle is down here in the corner. This means that this side is defined as the opposite because it's opposite the angle, and this side is the adjacent, being next to the angle. In this triangle the angle is in a different location. This means that this side is now defined as the opposite and this side is defined as the adjacent. Depending on the location of the angle changes whether we think of these sides as the opposite or the adjacent. The second thing to remember is this word, SOHCAHTOA. It is absolutely vital for remembering how to apply these formulas in trigonometry. O, H and A stand for opposite, hypotenuse and adjacent. S, C and T are all to do with the angle. S stands for sine of the angle, C stands for cosine of the angle, T stands for tangent of the angle. These are the three we're going to be using a lot of during this video. It's important that you understand how to undo these functions, because when I do a calculation I'm not going to get the angle, I'm going to get sine of the angle or cosine of the angle. So on your calculators there should be a button located above the sine that says sine to the power minus 1. You can access this by pressing the shift function and then the sine button. Your calculator should display sine to the power of minus 1. This means inverse sine. It will undo the sine function. Similarly, there is an inverse cos and an inverse tan. Let's have a look at how to apply these in a problem. In this triangle I'm going to start off by labelling it. The 6 cm side is opposite the angle, the 10 cm side is opposite the right angle, that is a hypotenuse. I'm not interested in labelling the adjacent, that will only confuse me. Then I start to write out my word, SOHCAHTOA, and if you remember from the original video on trigonometry, I write it in this disjointed manner so that they fit neatly into formula triangles like this. When they're in formula triangles it makes the whole thing much easier for me. Now the formula triangle that I'm most interested in is the one that contains the O and the H. So this one and this one are no good. This formula triangle tells me that if I'm trying to find the sine of the angle, I can cover that up and it tells me that S is equal to O over H. This means that sine of X, the angle that I don't yet know, is equal to the opposite, 6, divided by the hypotenuse, 10. When I type this into my calculator I need to type it in a very particular way. I'm going to press the shift function and then the sine button. This should give me inverse sine. I'm then going to type in 6 divided by 10. What this is telling the calculator to do is to do the inverse sine of 6 over 10, of the opposite divided by the hypotenuse. This will give me the missing angle, which is a value of 36.9 degrees. In our second example, I'm going to start in a very similar fashion. I'm going to label the hypotenuse because it's opposite the right angle, and this 7 cm length is the adjacent. This tells me that I'm going to use the CAH triangle. Now to find the cosine, I cover this one up. The triangle tells me to do the adjacent divided by the hypotenuse. So C equals A over H. This means that the cosine of the angle X is equal to 7 over 15. To type this into your calculator I'm going to go shift function and press the cos button. This will give me inverse cos and I'm going to type in 7 divided by 15. When I press enter this will give me the correct answer of 62.2 degrees as my missing angle X. Our third example starts in a similar fashion. The 8 cm is opposite the angle, the 15 cm is adjacent to the angle. This is going to be a tan problem. The triangle looks like this, and if I'm trying to find tan of the angle I'm going to cover up the T. It tells me that tan is equal to opposite over adjacent. This means that tan of X is equal to 8 over 15. So again I'm going to press the shift function and the tan button. This will give me inverse tan and I'm going to type in 8, the opposite, divided by 15, the adjacent. This will give me the missing angle's value, which is 28.1 degrees. Here are 4 examples for you to try yourself. Take care when labelling your triangles. Remember to use SOHCAHTOA to help guide you with which formula to use. Pause the video here to have a go at these yourselves. When you're ready for some help, press play and I'll go through the answers with you. Okay, so this first example, let's label it up. I have an opposite and I have an adjacent. This means that it's going to be a tan problem. So I know that tan of x is equal to the opposite 10 divided by the adjacent 7. This means that the angle itself, x, is equal to inverse tan 10 over 7. The missing angle when I type this into my calculator is given as 55 degrees. This problem down here, I'm going to label it up again. 9 is a hypotenuse and the 5 centimeters is an opposite. This means that this is a sine problem, and I know that sine of x is equal to 5, the opposite, divided by 9, the hypotenuse. So the angle itself, x, is equal to inverse sine of 5 divided by 9. When I type this into my calculator, I get a value for the angle of 33.7 degrees. This example up here, if I label it up, 12 is a hypotenuse, the 9 is an adjacent. This is a cosine problem. So I know that cosine of the missing angle x is equal to the adjacent 9 divided by the hypotenuse 12. The actual angle itself I can find by doing inverse cosine of 9 over 12. When I type this into my calculator, I get a final solution of 41.4 degrees. The last example, just take care with, because the triangle has been rotated, label it very carefully. The 7 centimeters is a hypotenuse as it's opposite the right angle. The 4 centimeters is an adjacent as it's next to the other angle. This again is a cosine problem. So I know that cosine of x is equal to the adjacent 4 divided by the hypotenuse 7. In order to work out the angle x, I'm going to need to do inverse cosine of 4 over 7. When I type this into my calculator, it gives me a final solution of 55.2 degrees. The next video you will want to check out is videos on further trigonometry, including the sine rule and the cosine rule. Thanks for listening.